This video will review some of the word problems that we've seen in the chapter and that will be helpful for the Chapter 5 test. Okay, in the first question it says, Miss Holton drives for 3 hours at a speed of 32 miles per hour. Then she drives another 2 hours at a speed of 45 miles per hour. What is her average speed for the whole journey? So in this question they're asking us to find the average speed. So we'll have to use the formula. Speed equals distance divided by time. Now in this question they gave us two different sets of information, so we need to find the total distance and divide it by the total time from the word problem. So let's go back to the beginning. Miss Holton drives for 3 hours at a speed of 32 miles per hour. That means she went for 3 hours and she went 32 miles each of those hours. So we have to do 32 times 3, and we get 96 miles for the first part of her journey. The second part of her journey, she drives another 2 hours at a speed of 45 miles per hour. So that means she went 2 hours, she went 45 miles each of those hours. So here she went 90 miles in total in the second part of her journey. So in total, Miss Holton drove 186 miles in total. So we take our total miles, which was 186, and we divide it by our total time. She drove for 3 hours and she drove for 2 hours. So she drove a total of 5 hours. So we're going to divide it by 5. Do our work on the side over here. So we have 186 divided by 5. 5 goes into 18 3 times, which is 15. Subtract it. Bring down the next number. 5 goes into 36 7 times, which is 35. Subtract it and you get 1. Now, we can't just add the 1 to the end of our decimal. We have to bring down a 0. So let's add a decimal and a 0. If we bring down a 0, 5 goes into 10 2 times. So our answer would be 37.2 miles per hour. Pause the video and try to do this one on your own. Okay, let's go over the problem. It says Mr. Mayones drives for 2 hours at a speed of 42 miles per hour. Then he drives for 3 hours at a speed of 40 miles per hour. What is his average speed for the whole journey? So we're looking for the average speed, and it's for the entire journey. So we need to do, first we'll write out our formula. Speed equals distance divided by time. Now in this problem, since we have two different speeds, we have to make sure we find the total distance for the entire journey. So in the first part of his journey, Mr. Mayones drove for 2 hours at a speed of 52 miles per hour. So each hour he went 42 miles. So we'd have to do 42 times 2, which is 84 miles in the first part of his journey. But then he drives for 3 hours at a speed of 40 miles per hour. So in the second part of his journey, he went for 3 hours at 40 miles each hour. So we'd have to do 40 miles times the 3 hours that he drove. We would have 120 in the second part of his journey. So altogether, Mr. Mayones would have driven 204 miles. So now we have the total distance. So we'll take our total distance and divide it by our total time, which was 2 hours in the first part of his journey, 3 hours in the second part. So he drove a total of 5 hours. So our division on the side over here, 204 divided by 5. 5 goes into 20 4 times, which is 20. bring down the next number, 4. 5 can't go into 4, so it goes into it 0 times. Now we'll add a decimal and a 0. 5 goes into 40 8 times. So our answer would be 40.8 miles per hour. Okay, here's another example of the average speed for a whole journey. So pause the video and try this one on your own. Okay, let's go over the problem. It says Kaylin drives for 3 hours at a speed of 60 miles per hour. Then she drives for 2 hours at a speed of 45 miles per hour. What is her average speed for the whole journey? So we're looking for speed, so we need to find the total distance that Kaylin drove. So in the first part of her journey, she drove for 3 hours at 60 miles per hour. So that means each hour that she drove 60 miles. So 60 miles times the 3 hours that she drove. So in the first part, she drove a total of 180 miles. Now in the second part of her journey, it says she drives for 2 hours at a speed of 45 miles per hour. So the second part, 45 miles each hour, and she drove for 2 hours, so we have to do 45 times 2, which equals 90 miles in the second part of her journey. So altogether, Kaylin drove 270 miles. Okay, so now we have our total distance. So we'll take our total distance and divide it by our total time. Show over 3 hours in the first part and 2 hours in the second part, so a total of 5. So divide it by 5. 270 divided by 5. 5 goes into 27 5 times. 2 left over. Bring down the 0. 5 goes into 20 4 times. So her average speed for the whole journey is 54 miles per hour. Okay, now we're going to practice another type of word problem. Riley runs at a speed of 5 miles per hour. She runs 2 miles from her house to town. Riley decides to increase her speed by 1 mile per hour. How much faster does she reach town? Okay, so for this question, we want to use a bar model to solve it. So we'll start with the first part. Riley runs at a speed of 5 miles per hour. So we'll draw our bar model. And it will have 5 pieces for each mile. So 1, 2, 3, 4, 5. So that represents the 5 miles in 1 hour, which we want to write that that's 60 minutes. Okay, so if the entire bar equals 60 minutes, then each piece would equal 12. Minutes. So this means Riley's running at a pace of 12 minutes each mile. So if she's running 2 miles from her house to school, so 1 mile, 2 mile, that would take her 24 minutes. But now it says she decides to increase her speed by 1 mile per hour. So since she was going 5 miles per hour the first part, now she would be going 6 miles per hour because she increased her speed by 1 mile per hour. So we'll draw a new bar model, except this one will have 6 pieces. So 6 miles in 1 hour, which is 60 minutes. So now each piece equals 10. So now Riley's running at a pace of a 10-minute mile. So each mile is going to take her 10 minutes. Now her distance from house to school is not going to change. It's still going to stay 2 miles. So she's still running 2 miles from her home to town, So 1 mile, 2 miles. So this time it's going to take her 20 minutes. So it says, how much faster does she reach town? Well, since the first time she ran 24 minutes, and the second time took her 20 minutes, Riley will reach town 4 minutes faster. Okay, here's another example. I want you to pause the video and try it on your own first, and then watch me solve it out. Okay, let's go over the problem. It says Betsy bikes at a speed of 4 miles per hour. She bikes 2 miles from her house to school. If Betsy increases her speed by 2 miles per hour, then how much faster will she reach school? So we want to start with our bar model. So Betsy bikes at a speed of 4 miles per hour. So we want to make our bar model, and this time it will have 4 pieces. So she does 4 miles in 1 hour, which is 60 minutes. So we need to figure out how many minutes it takes her to run each mile. So 60 minutes, she runs 4 miles. So if you do 60 divided by 4, you would find that each mile is 15 minutes. So Betsy runs 15-minute miles. She bikes 2 miles from house to school. So let's change colors. Ready? 1 mile, 2 miles. So it would take Betsy 30 minutes to bike from her house to school. But now it says Betsy increases her speed by 2 miles per hour. So she was biking 4 miles per hour, but she's going to increase it by 2 miles per hour. So now she'd be going 6 miles per hour. So we're going to draw a new bar model representing the 6 miles per hour. So this bar model will have 6 pieces. So she does 6 miles in an hour now, which is 60 minutes. So now each piece becomes 10. So now Betsy is biking 10 minutes each mile that she's riding. Now her distance from house to school doesn't change. It's still 2 miles. So she still needs to go 2 miles to school. 1, 2, so that's 2 miles. So now 2 miles will take her 20 minutes. The question says, how much faster will she reach school? The first time she went to school, it took her 30 minutes. The second time, when she increased her speed, it took her 20 minutes. So if you subtract them, you find that Betsy will get to school 10 minutes faster. Okay, here's the last problem, so pause the video and try this one on your own, and then we'll work through it together. Okay, let's go over the problem. It says Dominic bikes at a speed of 6 miles per hour. We want to make our bar model. And it will have 6 pieces. So he does 6 miles in 1 hour, which is 60 minutes. So since there's 6 pieces, which equals 60 minutes altogether, that means each piece equals 10 minutes. So Dominic bikes 10 minutes for each mile. And it says he goes 4 miles from house to school. So 1 mile, 2 mile, 3 mile, 4. So 4 miles would take him 40 minutes. But now it says Dominic increases his speed by 4 miles per hour. So he was going 6, but now he's going to go 4 miles faster per hour. So now that means he's doing a total of 10 miles per hour. So we'll make a new bar model, except this time it will have 10 pieces. and the whole bar model represents the hour, which is 60 minutes. So now we have 10 pieces, which equals 60 minutes, so each piece would equal 6. Okay, so now our distance from house to school doesn't change. Dominic is still biking 4 miles from house to school. So he's just doing it a little bit faster. So 1 mile, 2 mile, 3 mile, 4 miles. So now 4 miles would take Dominic 6 times 4, which is 24 minutes. So in the beginning, it was taking him 40 minutes to get to school. Now it's taking him 24 minutes because he increased his speed, so he's going a little bit faster. So if you do 40 minus 24, you would get 16 minutes. So Dominic is getting to school 16 minutes faster.